Now let's go to page 9 and pick up the equation for VDC average. Equation number 3. V peak rectified times 1 over, no, times 1 minus 1 over. Okay, so let's write this equation on page 3. 1 minus 1 over 2 times the frequency out times R times C.
What is R?
R is my 1K,
No, I know, but ohm value.
1 kilo ohms.
Oh, okay, sorry. Oh my God, yes.
It's the same as the circuit of page 1. I just added a 200 microfarad capacitor. Okay, so V peak rectified is 9.9 times 1 minus 1 over 2 times frequency out. Frequency out, there's a note at the bottom of page 9 that says frequency out is 2 times frequency in, because this is a full wave circuit. So what is my frequency in? 60 hertz. So I go 2 times 60, which is 120. R is 1K, so I will write 1K as 1E3. 1000 ohms. C is 200 microfarads. I will write that as 200. What is micro?
10 to the negative 6.
Negative 6. So I'll write that as E minus 6. And I do this calculation, and what do I get?
9.7.
9.7. If you get 10 or 11 or 12, it's time to pause and say, maybe I made a mistake in my calculator. Can it be more than 9.9? No. So that's what you have to remember. So 9.7. It can never be more than 9.9. So now, let's draw this graph on page 4. Half graph, B secondary. 0 in the middle. Peak value, how much?
Ripple peak?
No, this is B secondary.
11.3.
11.3. I'm on page 4. Page 4, top graph. Bottom graph, B out. So, I'm going to use the dotted line guides, and I'm going to draw a graph that I'm going to exaggerate it a little bit. So I'm going to draw the graph like this. That's what I will see on the scope. Actually, it won't be that much of a ripple. It'll be much smaller than that. Nope. This is 0. Thank you for pointing that out. This is 0. So use the dotted line is where your graph is. And I'm going to show the dotted line is the peak. So what is that value? Same as before, 9.9. So where do I show my 9.7, do you think? Nope, not where it ends. It's in between 9 and 0.9 and the bottom. So it's about halfway. So it's right in here. Because it's the average. So this is 9.7. You follow? So if it was a flat line, then it would be 9.9, but because it's 9.7, it's right, it's just below 9.9 and where the and the bottom is. Okay? So it's halfway between the upper part of my ripple and the lower part of the ripple. It's halfway in between there. So where do you think is the bottom peak, bottom point of the ripple? What is that voltage, do you think? If this is 9.9, and if halfway is 9.7, how much do you think is here? 9.5. Because it's between 9.5 and 9.9, which is 9.7. Everybody see that? There is a formula to actually calculate the size of the ripple voltage. So let me take you to page 8 for that. No, page 9. Go to page 9. Look at equation number 4. Page 9 equation 4 says V ripple peak to peak. So what is that voltage? It's this voltage here, isn't it? That's my peak to peak of the ripple, isn't it? If I use that equation there, I will get a value of about 0.3, 0.4, depending on the size of the capacitor. The bigger the capacitor, okay, the bigger the capacitor, is the ripple going to be big or small? Small. So the ripple becomes small. That peak-to-peak ripple becomes small, 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 until the voltage will be just skimming the surface of the peaks. Make sense? So this is, so the same concepts, we did it 3 times. 1 diode, 2 diodes, 4 diodes. The 4 diode rectifier circuit is the most popular. You do 4 diodes and you get full wave, you put a capacitor, you get a straight line. You convert from AC to DC. So we started out with 120 AC, we got 6.3 no cap, and 9.7 with cap. And this is